Okay, thanks again everyone for joining in. We are continuing with our journey with data with these free data sessions. And today, primarily, what I'm going to do is I'm going to take a very interesting and very important topic as part of the overall data concepts. You being as a data professional, some of you might already be working in this space. So the topic that I'm going to take is on data modeling and data modeling designing, right? So any projects that you do, any data related, as a data professional, when you work, you would be required to do something called as data modeling, which forms an essential part of any of your data architectures. So that's it, something that we will go. So we will look into the different areas across data modeling, different styles in data modeling, and well, what are the best practices, what are the key stakeholders that are involved in data modeling, how do you do data modeling governance, what are different tools that would be used. Okay, so that is something that we're going to use. Okay, now first and foremost thing, just to explain you the significance of data modeling, let me take you back to an image, like if you see this image, this is primarily, you see that it is more like a supermarket. You can understand that this is a supermarket, right? Now, if I ask you, supposedly if you have a list of groceries that you want, or you have a list of monthly essentials that you want to buy, and I give you an option that, would you like to go to the retail stores and would like to buy, 10 different retail stores, or you want to get it from a supermarket, which can also give you a lot of these things. I think definitely the answer will be as like a supermarket because it is like a one-stop shop where you can get all of these different things. And you can see going to a supermarket that gives you, right? The first and foremost thing is you see that the entire items that are products that have been sold in the supermarket, they are all organized into something called as different sections, right? So you see when you enter the supermarket, you go and see that there is a clothing apparel sections, then you walk forward and then you see that there is a electronics appliances, then there is kitchen utensils, then there is, groceries, then there is sports items. You have so many different types of sections which are there, FMCG sections and all. And each of these section, again, you can see that the items are very well neatly organized, right? So there are so much benefits that you get. So like, say, for example, you have the list of items in your hand, which you want to now buy. You can just go, which is the section that you're going to get these items each of. And then whenever you go into that section, you know that, okay, this is the item that I want. You, when you see, let's say you want to buy coffee, then you can also see that all the coffees are being kept there neatly, right? And you can also compare, you can select whichever the coffee, supposedly you want Brazilian coffee, you want Colombian coffee, you want a specific brand of coffee. So you can easily identify them, you can compare, you can get all the details, right? So your entire shopping experience becomes so meaningful, it becomes so simplified as compared to that. Supposedly, if I ask you that there is a nearby supermarket store, which also will give you all these items, but all the items that are present there are all dumped together, just like in a long dump, like a dump yard, they have been all dumped in. And normally, some of these companies, they do it. Their end of the seasons, they will just throw all their leftover items in a like a dump fashion, and they will open up that entire store for anyone who can just pick up anything that they want. So it is not very easy to find out, sometimes you find it very difficult to get things. So that is the one simple example I can explain you why, modeling of any kind of things, right? So for even supermarket, the model that they use is the modeling of the store, the retail store, the supermarket store. And this model that also you see, it also depends on what is the scope of the things that they want to sell. So supposedly, if you see that you want to get a supermarket which gives everything like a Walmart, or you have something like D-Marts and all, then you can see that you would be able to get all items. And then on the other hand, you have some specific stores which are only specific selling some specific kind of items. Like for example, you have the chromas, you have the digital stores, these kind of stores which are only selling digital items, right? So that is something you will see in data modeling also, that you have something called as an enterprise by data model when you see it, a data model for an organization, or you have something called a subject specific data model, which will be only catering to a specific line of business or specific use case or a specific subject area that it happens. Now, in data modeling, in very simple terms, is the whole process, how you start discovering, how you can start analyzing, how you can scope this entire data requirements that is coming from the business, whether you require to create an enterprise-wide data model or you want to create a specific, like for example, you have a credit card team. So you can create a credit card team data model, right? So that is arranging the data model, which will be for only for the credit card business, So these kind of things you can see forms the essence of data model and all the benefits that we have seen it, like to easily identify the data, arranging the data logically, discovering the data, documenting. All of it is something that you start seeing is also starting getting associated with data model. Okay. So data model, what see Dharma defines data model as per the Dharma book of reference is the most of a process of discovering, analyzing, scoping the data requirements, and then representing and communicating these requirements in a more precise form. So you know very precisely how the data would be arranged, how the data would be set in, and very easily, right? Not only identifying the data, but even when you want to place the data, you know where the data can be placed into the logical groups. And that's the reason the entire modeling of data, it starts with a conceptual logical, and these are the different stages that you'll find. It starts with the requirements gathering, then you have the conceptual model, you have the logical model, you have the physical models, right? Now, this is very similar to the retail store that I gave you the example, the supermarket, right? Like when you want to open that Walmart, it's not that they will just hire some people and they will start constructing. It go through different stages. Okay, so let's say I have this entire store. I have to do the design part of it. I need to identify, okay, what are the things I need to sell. Now, then I will logically divide this into different sections. Then when I divide it into different sections, then I also have to further subdivide. Let's say, for example, clothing and apparels as a section I have. So I will have to divide it further. Like I cannot put all my clothes in one place, right? I will have to separate it based on, the age group, kids section separate, men's section separate, women's section separate. Within even the men's section, let's say we have the casual wears, we have the formal wears, we have the footwears, we have the some of the other things that we want to sell, as part of the accessories, right? So these kind of things, it starts with that model of conceptual. Then you go a further level down, which is your logical model. And then the final step comes in, which is your physical, which you actually start bringing the products and start putting it, right? So it is very similar. You can, if you want to understand conceptual model is more like a blueprint. You have got that store design, you already have it. Now you are trying to break it into different logical areas that in which what is the sections that you want to put it. And once you put in, then in the logical design you also start putting nitty-gritties in it. Okay, this is that section for clothing, then this would be an area for men's, women's, and all. And then you further divide sometimes based on the brands. You have seen that, right? For example, if it is a jeans section, I have a Levi's as a separate, racks for Levi's jeans. I have something like Blackberries as a separate racks for Blackberries. And these kind of things, segregation makes the identification at the same time, placing any of these products very easy. So it becomes very clear, where I would be able to identify the products, I would be able to manage my products very well. Similarly, just think from the store manager perspective also. Like for example, I can keep an inventory track, which are my fast selling goods, which are my not so fast selling goods. And based on that, what will happen is I can also manage my inventory. Supposedly, at what point in time I need to place my orders to my warehouse, get in my products. All of it is, you see your entire inventory management system is linked with the entire ERP system. Basically, takes care about this entire managing this, the products very well. So same goes for your data sets also. You can easily keep a track of which are the data sets which are very highly frequently used by different teams. You see, if you go to your database logs, you can identify that. You can see that which are my where exactly my data, which data is being kept in. So if you want to put in the necessary security controls and all, that is also something that would be very easy. So the entire goal why we were doing this data modeling is to confirm and document the entire data sets which are there in my organization. It is not only catering to my current requirements, but let's say, for example, tomorrow there is a regulatory requirement coming in that they want an access to some of my personal data, like in data privacy, you have seen, right? Let's say, for example, The regulator now wants to understand where exactly your personal data is residing, and let's say if the customer has raised a request for data deletion, I should be able to delete my data. Whether it's hard delete or soft delete, that's a different thing, but at least first I need to identify where all my data sets are residing. So data model helps in giving you not only a current perspective about the data, how the data is residing in your organization, but also to your future, any of your requirements that is coming in and all. It also helps you to identify the gaps. So in the gap analysis perspective, let's say, for example, there is a request that has come in from the business, but you can also very upfrontly give a response back that whether you have this data or whether you don't have this data. So these kind of things that will come in. Now, just we will start going to the design of the data models, but before that, some of the key things. So what are the things that will be acting as inputs as part of the requirements of my data model? So first and foremost thing that you will have to try to see what are the types of data sets that the data model is going to handle, right? So for example, in the retail market. So I always say that associate your data model with your supermarket. If you keep the supermarket example in your hand, you will always think. So let's say you want to keep the supermarket, so you know what are the products and things that you want, right? So same thing, when you want to go for your data models, then what are my existing data models that are existing? What are my databases or the data sets that I will have to bring in? What are the data standards that I will have to follow? Are there some standards in the organization that I need to follow? What are my business requirements, whether I want to create an enterprise-wide data model or whether I want to create a business-specific data model. That's a very important thing. That will also drive your how your data model will start, coming out as an outcome, as a final outcome. Then the data requirements you're getting, the data architectures, then the enterprise taxonomy, how the data sets are being interlinked with each other. All these kind of things will come in. Now, now, once we design the data model, the data should have start coming in, right? Right. So, for example, who are my suppliers? Like in my supermarket, I will have to identify my suppliers who will have to supply the products, right? Similarly, on my data model perspective, I will have to start identifying who are the people who are going to feed in inputs. One is the data they will put in, but also they will gonna provide me inputs when we are designing the data model itself. Like the business analyst will be there, you will have the business professionals, you'll have the business owners, right? All of these people will start giving their requirements. Then you will have your database administrators, you have the data architects and all. They would be also trying to give the mappings, like for example, the target data model that you create, which data should be going and fitting in where? Can I bring my data in my original form, or do I need to apply some kind of a transformation, some kind of a massaging, some kind of a cleansing? All of it is something that I will start doing it. Now, another thing that I start doing is a lot of these, when I would be creating my final data model, I might also have to start capturing a lot of metadata information, right? So that's the reason your metadata administrators can also start giving you a lot of these additional information. Now, activities perspective, we have the PDCA kind of an approach. We have the planning, control, development, and operations. So you can see that it starts with the planning, the data model phase. Then we have the design, which is your building the data model. In that design, we have three main stages, which is your creating the conceptual data model. We have the logical data model, LDM, and then we have the physical data model. Then once we create the data model, it has to go through a review process, right? So that is nothing but your control. And then you have the managing the data model, which is your operationalization part of it. Okay. Now, and on the other side, so a lot of these activities, you have the data modelers, you have the data business analysts, architects who would be part of the activities of these activities. Then on the deliverables, you see the conceptual data model, the logical model, physical model. So all these comes out. Normally you'll see the conceptual logical model could be output in using a specific data modeling tool or technology, or you can also have them as paper deliverables. And physical data model is primarily the data model that you'll see being physicalized in a solution. You have any of your databases, your SQL, NoSQL databases, and all. You have seeing that is being the construction that is more tangible that you will be able to see. And then who are the users of this data model or nothing but the consumers of your data model? So you see the business analysts, data modelers, database administrators, developers, software developers, stewards, quality analysts, data consumers. So these, and I'll say the data model is something that everyone within the organization is going to use. Mostly your data set of community of users will definitely be there, but you'll see the business teams also. But CXOs and all might not require or might not be able to, you will use the steering committee, the CXOs and all, you'll see that they might not be the direct consumers. They might have to depend on the leadership groups or these consumers who can start providing them the data model outputs. So while we do this, so here you can see that a lot of these inputs that is coming in, you take these inputs, you start building, and then you a lot of these unstructured information that you would be collecting in the raw format, you start putting them into a more of a structured information. And data modeling also has evolved over the time, where initially it was more, associated with your structural data, but now we have unstructured data and NoSQL data which is being there. So non-relational data which is also being there. So data modeling styles have also evolved over the years, right? So now we have schema-based modeling, we have pattern-based modeling. So based on the type of the data modeling styles have also evolved over the years. Okay. Now, primarily, this is more with respect to how the data models have, what are the kind of significance and what is the kind of thing. So this is a distribution of the kind of a percentage weightage of the entire chapter on data model. Now, I'll just come on this in some time. So this will basically give you. So if you can see the data modeling style or the data model roles, what are the 10 roles of data modeling and uh, how do we have basically split them into your suppliers, the participants of the data modeling exercise, and the consumption layers, they would be consuming. So here you can see that the business professionals, business analysts, so they would be providing a lot of information, but they might not consume. But you have your business analyst who will supply, participate, as well as they will be consuming. So developers, metadata admins, and all. So you will see that based on their roles, you'll see them. It is not that it is that they cannot consume or they might not be able to participate. So as and when we will be doing the data modeling exercise, wherever you find them, giving valuable contributions, definitely their inputs should be taken in. A lot of times, the table that you are able to see, might be fit only for an organization which is just starting with their journeys and all, but there would be a lot of mature organizations already there. So there in those kind of scenarios, you see also some of these people, like for example, the software developers, they might be able to participate in their data modeling activity, or the data quality teams, they can be participating in giving some of the data quality maturity to understand the existing maturity of the models also. So you'll see that it's also depends on at what stage of the maturity the organization is. That will also depend. But as you can see, it is not like a one person's effort. Data modeling is something you have to understand. It's something that requires a lot of collaborative effort with the different teams, understanding, working with the different teams, one of the with the business teams and all getting validated with the IT teams and all, right? So you will see that. Now here you can see it's a map of how the entire data modeling, the topic has been split across. So it starts with the business drivers. What are the goals and principles around that? Within the goals and principles, you have the entire formalization, scope definition, knowledge retention. Then you have the different types of activities that are involved that we have seen. Then we have the different types of tools that would be used. What are the best practices that you used as part of it? What are the naming conventions? What are the ISO standards that are associated? How you do the data modeling aspect? And then the last part is the governance aspect, right? So this is how the entire chapter has been split across. Now, if you see, this is primarily the part one, which is more of the overview, and then you have the deep dive, which has the more granular understanding about these data modeling. So when you create a data models, what are the actual steps that you do? So let's go through it one by one, and you'll get an idea. Now, starting with what are my business drivers, right? So data models, there are four main business drivers you can say data with respect to. First is It provides a common vocabulary, like for example, between the people of the data users or the people who would be want to use, understand the data in the ecosystem. So it gives a common vocabulary around the data. Second thing it does it also provides a documentation perspective. So it captures and document the explicit knowledge about the organization's data and the entire ecosystem. Second thing. Third thing that it does is it provides a primary communication tool during projects. So a lot of time during the data projects are there, data models is something that keeps on coming up in the conversations. Every team wants to understand what's the data model, what is the relationships between the data and the data model. So it also acts as a communication tool. And the fourth point is it also acts as a starting point for any of your customization integrations or replacement of an organization. So you'll see an example for that is supposedly you have already using a core banking solution. Okay. Now that core banking solution might already having a data model, but now you want to, let's say, want to move to another solution, a better solution. Let's say you are using Infosys Finacle and now you want to go for Oracle iFlex. So something like that. A lot of these clients, they keep on changing their solutions, maybe because of the multiple reasons around that. But one of the key component is the data model they have to understand. They don't want to miss on. So data model migrations and these kind of things, exercise that keeps on happening. So that is also a key. You'll see a driver that will be that is associated with data models. Now, what are the goals and principles? Different types of goals and principles. Now, normally we do everything that we do has to have certain kind of a goal, right? Now, that is where the goal of the data model is also to understand what is your current and your future business requirements, and then based on that, we try to create a overall scope. And this data model serves as an input to some of your future projects that you might be doing. Let's say, for example, you want to build an MDM, you want to have. So you'll see that during the data modeling exercise itself, you basically try to align these objectives as part of your data modeling exercise. So these kind of things, and one of the thing that has been already identified or has been proven is when you are able to effectively manage your data, it also starts giving you a lot of the benefits. Any of your future projects and all that you will be seeing, they start running very smoothly. If you have a very good understanding of how your existing current data is. Now, based on that, you will see that there are different perspectives that is associated with data modeling with respect to the goals and principles. First is the formalization. So when we define the data model, so what happens is one of the other important component is from a documentation perspective or from definition of the data structures and relationships. So an organization might already be using an application or an existing data systems and all, but over the time they have not defined how the data model should be. Somehow it has been more of an ad hoc basis. It has been created based on the request that is coming in. They just source in the data, they just provide in the data. So these kind of things, ad hoc basis requirements which have been created becomes very much difficult to manage. So formalization, formal definitions, or having a proper interconnections and relationships established, created, defines a kind of a proper discipline structure, you can say, to the data. And it also creates a lot of anomalies, data anomalies that might be created or redundancies. So we'll see as we go forward one of the very popular method, how you basically remove your data redundancies is nothing but normalizations, right? So you also start understanding the redundancies and start removing these redundancies in the data. That is one thing. Then on the scope definitions perspective, what data model also does it also starts explaining what are the boundaries that are associated for data implementations, what are the, how the data is being used by the different packages, different projects, different initiatives in the existing. So scope definition becomes very clear. And documentation, as I was mentioning, right? So documentation, it also serves as a documentation for any of your future projects. Any of you start understanding how your data is associated, what type of data is there, what is the relationships of this data that is existing. So it also start helping a lot of these business people like business professionals, project managers, analysts, modelers. A lot of these people you'll start seeing will be getting benefited of this. So data model becomes like a reusable map, you can say, that will help the business professionals, project managers, analysts, modelers, right? So these different set of people that you will be able to see, they would be able to understand the data and they can start using this. Now, what are the different types of concepts that are associated, right? So first thing is under your data modeling and data models, right? Now, first thing, when you create the data models, right? So it's one of the most, you'll say that one of the stages, if you take any of your software development or system development life cycle. So data modeling is one of a key step that is always included as part of it, right? So you can say that data modeling, sometimes you might start thinking that data modeling is only associated for your database design or some of these things. But you take any of your systems, any of your technologies, right? So even if you take any of the technology architectures which you have, data architecture will be part of it. And within the data architecture, you need to understand how the data will be deciding, what kind of relationships that is there. So that is nothing but your data modeling, right? So you are trying to represent the data, what kind of pattern that will be used. If it is more of a streaming data, then how the data would be, the data residency is that you are using a message broker for holding the data. When after that, whether you are trying to move it into a more structure and then start storing the data into a final target table, right? So these kind of things all will be starting with your entire data modeling, right? So data models primarily will help you to understand this. So there are, for doing that, just like, whenever you want to, creates something, you create a kind of a diagrammatic representation for that easy understanding. Similarly, in data modeling also, what you're trying to do, data model also, we'll try to use certain kind of symbols, text labels. You can start representing, visually representing the data so that, at any point in time, if someone else wants to start understanding, right? So we have different types of diagrammatic representations like ERD diagrams, UML notations, some of these other ways of representing that this diagrammatic representation can start also helping you to understand what is the kind of relationships that the data sets have with each other. Now, within this, you have different types of data that are being modeled. These are being classified into four main types of data. So first is the categorical informations, the categories that you have. Like, say, for example, you have this category information would be useful for categorizing some of these things. Like, for example, customer categories or market categories you have, or the business sectors or business categories. You have the business sector classifications. And if you are some of you are from the industry, you will understand business industry classifications. Or let's say, for example, you have product classifications. So this kind of data is one type of data that you will find in a data model. Second type of data that you will find will be more on the resource information. Like, say, for example, the resources that you will require for other any kind of processes. Like, for example, you have the customer related data, product related data, suppliers, facility, organization related data, right? So resource entities are also something that you use. Resource information is on other terms you can consider is like your reference data, right? So data that will be referenced across by some of the other things. Then you also have the events or the kind of transactional related data that you can say, which is nothing but your business events related data. So this data is nothing but is also the kind which acts as an input to your events related kind of types of data. Like, for example, you have the customer orders, you have the invoices, you have the withdrawals, you have the transactions. All of these kind of things are like your more transactional in nature. So these are like your business events related information. Then you also have something called as the transactional related information. So this transactional related information are more like, you have which are more details, right? So like, for example, or which are more voluminous in nature, so like, for example, you have the click streams, the internet clicks that you do, your social media related data or your sensor related data. So this kind of them are has to be more detailed because at every point in time, you keep on seeing that they would be rapidly changing, they would be continuously changing and very voluminous. So these are also like your big data kind of data, which is there. Now, this kind of data sets would be applicable for your data which is at rest as well as data which is in motion. And you'll see that based on that, based on the type of data sets, whether you want to use a more of a transaction related systems, whether you want to use any of your event related systems, messaging related systems to handle this data. So it depends on what type of data you will be required, and the data models that you would be creating accordingly will be changing. The third component is what are the different actual components when you're creating? What are the key components that are associated with your data model when you create? Now, there are certain key components that you will start, seeing or understanding, which are associated with your data model, which are nothing but your entities, attributes, dimensions, and these kind of things. So we'll just go through each of them and we'll try to understand what are each of these components associated. Now, this is more like a data modeling process that I was showing you. You know, in the data modeling process, you have different types of these categories, right? So you first identify what are the different types of entities. Now, entity in very simple terms, you can consider is like something of significance where the organization wants to collect and store that information, similar information. Now, how do you identify entities, or what are different types of entity categories that you can think of? So these categories you can say are of also different types. Okay. So we'll try to see how do you basically define these entity categories. So under your entity categories, you have something called as, or you start asking the different types of questions. So first question that you ask is the who, you know. So who will include the different types of entities which are more the nouns that you would be able to see. Like, for example, the people, the person, the organization of interest, or these kind of things. So some examples under your entities would be like your customer, your employee, your patient related entity, right? So these are something which are more static, which will have more static related informations you can consider, or the data which is about someone, like your student, you have passenger, you have competitors, right? These different types of entities that you would be able to. The second type of entity categories would be the what type of entities. Like, for example, you can use something like, for example, the products, the services, the raw materials, right? So what type of entity, what type of data is that? Like the finished goods or book as an entity, or you have something called as the classes, or, these kind of things that you have. So that would be the what type of entities. Then you have the when type of entities, which will be giving you the entities information, which is more about the time and location, so that kind of things. Like, for example, you have calendar, you have date, you have time, then you have location, those kind of things. Or location, yeah, we can also consider location under when, what place it has happened. Or we can keep location also under the where part of it, where exactly these things happen. So your address related, you know, things, your address related information will be there under your where type of entities, the IP address, the website URLs, or those kind of things. Then you also have the why type of entities. The why type of entities will type to tell you why this and has happened. So it will capture more of your transactions. The transactions like the orders, the complaints, the inquiries that is coming in, right? So all these kind of things will come under your whys. Then you have something called as your how, you know. So your how type of entities will be including how this entire thing has happened. So let's say, for example, is it because of some kind of an invoice that has come in? Is it because of some kind of a contract? It is because of some kind of an agreement, right? So all these kind of things. Now, if you see why these are called entities, because all the data sets which are associated to these will be available here, right? So I'll come on this again in a minute. Then you have the measurement kind of entities. Like, say, for example, if you want to measure something like the sales, the balance, the payments, right? So all these kind of things can be anything that is giving you some measurements, then that would be under your measurements. Now, if you see why I was mentioning is uh, entity as a definition, what I was mentioning is something of significance where the organization wants to capture and store this information, similar information, right? So all your information about your customer, you are keeping under your customer ID, like the customer ID, customer name, customer date of birth, customer first name, middle name, last name. You have the customer's, the ID number, or your customer's date of marriage, date of birth. These kind of things which we want to store about my customer, you want to keep it under my same entity, right? So that is the first thing that you will be able to see. Now, this is one thing that you are able to see, that is your entities. Then the essential component under your entities is nothing but your attributes, right? Now, before we go to attributes, let me just cover some of these components associated as part of your the entities. Let me just see. Okay. Okay. Now we have once we have these entities, the uh, the second or there are a lot of times we can see is we use it associated with your entities, which is nothing but your entity aliases. So something that a lot of times that we use is as an alias, entity type, which is that we might be using. So what we have is we also sometimes use some of my aliases for associating my entities, right? So like I might be calling, an entity by some other name, or so that is primarily the whole concept of aliases whenever we are, want to call out that entity with some of my other things. So normally entities you'll see would be represented by square boxes, so square boxes as in like my rectangles, you can see you can see like you want to write a student entity, you want to write a customer entity, so you can write it. Now, these entities are also, you will see, of different types, based on the type of the models that you have. Let's say, for example, if you go with a dimensional modeling as one of your modeling style, then you'll see these entities would be also of different types. So there you will be finding dimensions, you will be finding, uh, fact and dimensions. Then you have something called as the relationship types of entities. You have the hierarchies types of entities. You have the anchor kind of entities, right? So these entities are also different. So like, for example, dimension entities will capture the dimensional type of data, like any type of data that is more static in nature, that is not going to change very frequently. Like, for example, if you take customer dimension, so what are dimensions or what details of my customer is not going to change? So, for example, I have the customer ID that is not going to change. The customer first name is not going to change. Then you have the customer date of birth is not going to change. Customer last name. So maybe the customer last name might be changing, but maybe once or twice it will change. It will not change very frequently. So those kind of data sets which are more or less, slowly changing or not very frequently changing would be captured in your customer dimension or in the dimensions. Then you have the facts, which will be having more of your factual related information. So facts are primarily, you'll see, capturing factual data. And within the facts also, you have different types of facts. Like, for example, you might have transactional facts. These transactional facts, all the transactions, like, for example, if you have an account dimension, which will capture all the account related data, then the corresponding transactions that is happening in the account, you'll find it under your account fact or transaction fact, account transaction fact. All the transactions, like for one account, all the debits and the credits that is happening will be available in the facts. So these facts also you can basically roll it over. Let's say, for example, if you want to take now an end of the day, balance or end of the day transactions, then you can have something called as your end of the day your results getting available in your daily fact, in your monthly facts, right? So these kind of things you'll be getting. Then you have the relationships, like for example, if you want to find out customer and accounts relationships, so you can have like a customer account relationship table that will basically help you to give the what is the relationship between your customer and account. Like, for example, you have one account A1, in this account A1, you have three customers, C1, C2, C3. Now, these three customers are associated with my account. Like, for example, this is me. I have my wife and I have my, son. So I am the primary, my wife is the secondary holder, and my son Mike is a nominee. So they are basically these three customers are there who are playing three different roles on that account. So that kind of relationship I can have it in my relationship kind of table. Like this, you have the hierarchies which will store your hierarchical information. Like for example, the different branches which are present. Their locations, how are they uh, associated, even the employees hierarchies. So different types of hierarchies will be there. Now, based on that, you'll see these different types of and then anchor tables are basically used for anchoring the entire these entities, right? So it becomes as a starting point, which will be useful. Now, these types of entities that you're able to find, these entities are also different based on the type of data they could be also of different types. Like, for example, you have strong entities, you have weak entities, you have associative entities. So weak entities, strong entities, and associative entities are also different types of entities that you'll find. So these entities that you find, strong entities are those entities where, which doesn't require any other entity as support for its existence. They can all be existing based on, they have an own independent existence possibly. Like, for example, you have customer entity, right? So customer as an entity doesn't require to have any other entities. This is not dependent on any other entity for its existence. But if you see, if you have a transaction entity, or like a daily fact, if you have. So this fact table, daily fact, is primarily will have to depend on my transaction fact for its existence. Because based on all the transactions that is happening around the day, I will see that a record will be getting inserted in my daily fact. So accordingly, you'll see that the daily fact becomes a more of a weak entity because it has to depend on my transaction fact for its entity existence. And then you also have the associative entity, like for example, these relationships, which has dependent on these different entities. Now, these entities that you have, so that you will start understanding that there are different types of essential characteristics that are associated. Even our book of reference also mentions these. So first is the clarity about these entities. So each of the entities that you are defining. Now, is there a finite number that we say we should only have 10 entities in a data model, 20? It is nothing like that. You can have as much entities and all. So that's the reason one of the few of the essential characteristics when you're creating the data model, the entities is it should have a clarity. The definition should be very clear and there should not be any ambiguous or, something that it should basically give an essence why it is being created. Accuracy, primarily when you're defining the entity, the definition should be very clear. And even a non-technical person should be able to understand, the business teams should be able to understand. And the third thing is the completeness thing, right? So completeness primarily mentions that the definition should be well understood, or, it should be understood by everyone, right? So that's the one. So here you can see that it is entities. Now within the entities, you have something called as the properties or the descriptors that are nothing but your attributes. So attributes are something that you see will be part of your entities, and these will be capturing the granular information, right? So for example, you say that it will describe these entities. It will help you in capturing the underlying data within my entities, right? So you can see that that will be how the attributes would be stored. That would be useful, right? So again, is there a number of attributes that we should have or we should not? It's nothing like that. It could be as detailed as possible, but if you see, these attributes are helping my entities in storing my data. So within my attributes also, there are different categories of attributes that you will be find. Some of my attributes that you will be finding would be, unique in nature. Like for example, you have the customer ID, which will be unique. You have the ID numbers of the person, which will be unique. The phone numbers might be unique. So these kind of things would be some of my attributes that might be the thing, unique kind of. The sum of my attributes will be simple. They can't be further subdivided. Like for example, you have the phone number, you cannot divide this, but you have a attribute which is composite. Like for example, you have the name of a person. So you can have my first name, middle name, last name, like this as a composite attribute. Then you also have some attributes which could be derived attributes, right? So derived attributes are those attributes which will be derived from the main attribute. Like for example, you capture the date of birth from a person, but using that you can calculate the age. because what happens is if I start asking the age of a person, I sometimes don't get my exact age, right? So because of which there might be data anomalies that would be coming. Now that because of that, I will use a deriver. And here each of these you can see are the symbols. Like for example, ellipses are normally used for showing the attributes, and you have the dotted ellipses that will be useful for showing the derived attributes. Then key attributes, which will be useful as a key for identifying the entire unique record for that specific entity. So like for example, the roll number, the customer ID, the account IDs. These could be the keys. You have under the keys the primary key, foreign key relationships that would be useful. Then some of my attributes that you will find will be the multi-valued attributes, like they can store more than one values, like for example, address information, phone numbers. Some of them would be multiple attributes, multi-attributes. Some of them would be single attributes. So like this, you will find that will be different types of entities, attributes which will be present in the data model as well. Then as you go forward, you also start seeing that, the entity types that I've shown, Now, what are the different types of relationships? So coming back here, the other important component is the relationships between these entities, right? So now we have understood that the different types of entities which are there. Now we will have to start creating the different types of relationships, right? Now, like for example, when you want to basically take a relationship, when you want to start showing a kind of relationship, you want to see that how the relationships could be drawn or could be represented. Now, that is very much important because you will have so many different types of, you will have these identified. Now it becomes very much important that you should start showing these kind of graphical representation about these. These relationships will help you to understand what kind of relationships that they are bringing in on the table between these, right? So that is important. So it will help you in very easy terms. It will help you to understand how the entire data is associated. So here you can see, like for example, you have that relationship over here in the form of a diagram we have shown. The relationship between student and courses, right? So you can see the student attending the courses, and I also want to show the instructor relationship with my course, right? So like this, you have different types of relationships, which we also called as the cardinalities and the relationships between them. So the symbols on the line that you can see, they basically capture the rules, which is nothing but the cardinalities. So here you can see that within the cardinalities, we can have different types of cardinalities. Like for example, you have one-to-one relationship, you have one-to-many relationship, many-to-one relationship, and many-to-many relationship. So this depends. Like for example, student with an identity card will be like a one-to-one. One student can have one identity card, and one ID card could be also associated to one student. Then similarly, you have customer to orders, like the customer, the relationship you can see is shown in the form of a diamond, in the form of a diamond box, which shows and connects these entities, and it shows that relationship. So the student has the identity card, and what kind of relationship is shown by the cardinality, which is the one-to-one, one-to-many, many-to-one, and many-to-many kind of relationship. So this kind of relationships cardinality help you to understand what kind of data or relationships that I want to establish also. So that is something also you will be able to see the relationships I would be able to create. And then I will discussed about the attributes that we have. Then we have something called as the domains, right? So the domains primarily, when we speak about the domains primarily speak about what type of data it would be there, right? So it's a complete set of possible values that could be associated, right? So for example, what are the characteristics or what are the type of data that it would be having, right? So some examples that if I have to just mention with respect to what are these different types of domains that are available, and what are the ones that could be associated. So we have something of these, like for example, we have something we can speak about the domains. Like for example, if you have the employee hire date as one domain, or we have so that domain for employee hire date, which should be what kind of values that it should be having. So if we take employee hire date, so whether it can be having the higher date values, the employer higher dates would be there, right? So in this, we define that okay, all the this entire domain that will be the date domain that it will consider, what are the possible valid values that it will be covering or it will be consisting. So domains are defined, you can consider in different ways, right? So domains of data also helps you understand what are the categories of data that you will be having, right? So for date, you can consider that it can consider the date type, what type of data that it would be having, the standard types that it would be having, what is the format of the dates that it would be having, then what is the list of valid values and what are the values that values that it cannot have, right? So those kind of things will be there. Then what is the range of values that it can be having, the range of dates that it can have. And then there could be certain kind of rules that I can mention, like for example, the based on the date of, as the date is expiring. Like for example, this is something that I use during my bookings. So as you see that the booking date is, becoming very near, you see that the prices keeps on increasing or goes on increasing. So these kind of things that you will be able to see will be more useful for your domain related creation of your data model. Now, once you identify this, the next thing that you can see is the different types of data modeling styles that you have. Now, within the six common data model schemes that you can see includes your relational model, your dimensional model, your object-oriented model, your fact-based model, you have the time-based model, you have the NoSQL-based model, right? Now, each of these model has a specific significance, has a specific difference between them because and they are being used for a specific reason. So that's reason what is something that differentiate and how what is some of the things that you would be able to see. Let me just show it to in the form of a diagram. So here you can see that these are my six different types of data model styles. And each of these my data model styles, you can see there is a specific, like for relational, I can use different types of notations. Like we have the information engineering, we have the IDF1X notation, we have the Barker notation, we have the Chen notation, we have the Crowfoot notation. This will all be useful for your relational kind of your data modeling style. Supposedly, if you want to go for a dimensional based, so you have the dimensional based modeling. Like for example, I showed you the entities, the dimensions, the facts, the relationship, hierarchies, and all. Those are the dimensional types of data modeling concepts that you have. You also have the object-oriented data modeling, which uses your EML style of data notations. You have the fact-based data modeling. So there you have the object role modeling and the fully communication-oriented modeling, FCOIM based modeling. You have the time-based modeling. So there you can see the data vaults, which is getting popular these days, where you use the concept of hubs, satellites, and links, right? And do your data modeling. And sometimes you also use a combination of them. Then you have the anchor modeling, again, used along with your dimensional modeling. A lot of times you have that. I'll show in some time the way it looks. Then you have NoSQL based data modeling. There are different types of NoSQL database. You have the document data, column-based data modeling, you have the graph-based data modeling, you have the key value data stores for them. So each of them will be depending on what kind of data stores that you are having. So here, again, you can see that these data modeling styles, each of them will also depend on what type of use case that you have. Now, each of these, if you see, what is the kind of reference that, let's say, for example, if you want to understand each of these, with respect to what is the kind of, I'll say, what typically you will see, right? So whether we want to use the types of data modelings that we have seen, the conceptual data modeling, right? Now we also want to see a kind of a mapping between the data modeling style that we have over here with respect to the data modeling style that we want to use, right? So for example, let's say, for example, we want to go with a relationship-based modeling. Now, in that relationship-based modeling, can we start using all of these relationship style modeling, or can we use only one of them? So this table will help you to map, whether we can, use what type of modeling for that. In relational, you can see that we'll go over all the conceptual, logical, physical model. in the relational based modeling. In NoSQL, we have the physical based modeling going with each of the types of different types. So this table helps you to understand at what stage you're gonna do your conceptual modeling, at what stage you're gonna do your physiological modeling, at what stage you would gonna do your physical modeling. So that is primarily also gets covered around here, right? Then we also have something called as my normalization, right? So normalization is something which is, in very simple terms, is to remove the redundancies in my data. And there we have different types of normalized form. We have the first normal form, second normal form, third normal form, BCNF, voice code normal form. We have the fourth or the fifth normal form. So we'll just see that in some time. And then we also have the abstraction that we want to have with respect to subtypes, supertypes that we want to add as part of my data model. So that is also something that we just want to see. Now, just to start with, as I was mentioning, what are the different types of activities that are associated with data modeling? So the typical data modeling style, it starts with firstly with your concept, the plan that you want to have, right? So it starts with your planning phase. So in your planning phase, when you go under your planning phase, there you will be trying to get all the different, the diagrams, the definitions, aspects, all of this is something that you will start creating, when you are doing these activities, right? So when you start doing these activities, you start also identifying who are the suppliers who would be providing and all. Then you have the participants who would be actually participating in creating this data model, right? So there you can use different types of forward engineering style where you create a conceptual logical model and the physical models. And then reverse engineering is where now whatever that you have created, you are trying to reverse engineer to identify the mappings, identify. So this is more on the traceability aspects that you can understand, or the source to target mappings that you create. It's more on the reverse engineering side. Then you review the data model for data quality controls, for continuous improvements. This is primarily happens when the consumers who start consuming the data model, start utilizing the data model, start understanding whether the data model is fit for purpose or it requires to go undergo some of the other modifications. And lastly is how do you start maintaining the data model? That's the governance aspect. So we'll start looking into each of them. Now, in my conceptual data modeling, when we start with my conceptual data modeling, so it starts with a kind of a blueprint, So when the conceptual model, what we try to do, we try to identify, my data model at a very high level, So in my conceptual modeling, you can say that I basically, start identifying what is my scope of work. So in my conceptual model, you identify what are my subject areas, or what are my business areas. So once we start doing that conceptual modeling, in that perspective, what we try to identify, you define what is my scheme, whether this data model that we want to build, whether we want to build, for a specific subject area or for an enterprise subject area, that is you define what is the scheme that you want, what kind of notation that you're going to use. So we have seen so much different types of notations, right? So whether we're going to have an object-oriented risk modeling, whether we use the dimensional-based modeling. So these kind of things also I start identifying as part of my, this modeling creation aspects. Next is primarily once we identified a lot of these components in this, then I start creating some of the initial aspects about my data model, right? So in that we identified the entities who are my attributes, which are part of my attributes. So all of this is something that I, start capturing that. And once we identify this conceptual data model, then we start going to the next stage, with respect to how we can start putting this in place, with respect to start building the logical design part of it, start translating into logical designs, the logical puts, and then we start defining it. Now, once we do that, once we have created this logical modeling, you know, then we identify some of these, the different, and when we get a sign off from the business. So this sign off is very much important because just to understand what is the completeness of this data model, whether it's something that is complete, it is something that is missing any of these attributes or some of these components, it's something that you will start seeing that is very much important. And that's the reason getting a business sign off is something that is always important, that is always required whenever at any point in stage you are creating the data model. Right? It primarily, a lot of times defining the scope of the conceptual model is also important because that also leads into a kind of a lot of failures, then in the logical data model is the actual modeling stage when you deep dive into you take the conceptual data model and you try to deep dive. Now, so this is in the logical data model, you start identifying what are my entities, what are my attributes, my domains, the relationships between them, and you start creating a logical design, as part of it. So let's say, for example, you have a conceptual model which might be very high level, that is something might not be very sufficient or might not be very useful. So in the uh, logical data modeling design is where now you want to start designing the logics between them, the data model, how it might be looking like. So that is where you start transforming them, or you start translating them. So let's see that how the logical data model design might look like. So for example, the conceptual data model might have the location, store, salesperson, sales, product, customers, and the relationship, which is a very high level. But now I can start detailing it out. I identify the cardinalities between the data sets. I start identifying the relationship between them, So it starts now taking a more, because now I'm associating the attributes part of it. I'm associating the relationships part of it. All of it is something that I start creating. I will start coming in this. And then the last stage is your physical data model. So in your physical data model, what you do is you start creating the physical design. So here you resolve all the logical abstractions which is there. So in physicalization, you also start identifying what is the database or what is the data store where you want to create a physical design. You want to translate the logical design into some physical form. So let's say for you can use an DB2, you can use an Oracle, Teradata, Sybase, any of the different databases which are there. And one of the key important aspect of the physical data model is this will include a lot of my physical data objects. Like you might have to create some of your, views on top of it. You will have to use some synonyms. You will have to use some partitioning between the tables, some indexing. So all of it is associated with your actual physical models, right? So in your physical model, your database developers will be playing a very key role, because they will be creating this entire data model actually into my target data model, which I'm the target database that I'm going to use. And for that, they have to have very good expertise, right? So if you have decided on Snowflake, so they will have to go and understand, how that Snowflake would be, what are the syntaxes that are being, what are the nomenclatures that are being used. So all of it is something that you want to use as part of it. Then you have the keys and the associations that you can use. So in the keys, what are the keys? What is the primary key for India, and what are the primary key constraints that you want to have, like unique, null, non-null? Those kind of things will all start coming in, right? So, and here you can do the indexing, partitioning, creating of the views. All of it will start happening in the physical data modeling. Right. So this physical data modeling is more for the technical set of users, but this is a stage where now you want to create all the final, I'll say, the end state. This is something that will be accessible, that will be used, right? Now we also have something called as when you're creating these activities, what are these different types of we have seen these activities that are associated. So in this, the role of the data modeling, that these different people will start playing a very important role, like who is going to supply the data, who is going to participate in the data modeling, who is going to consume. All of it will start getting associated as part of my this stage. So across them, what are different types of tools that you might be using as part of this entire exercise? Is primarily the different types of there are different types of tools and techniques that are existing that you can start using when you're trying to have this, right? So like for example, you can use some data modeling tools, in the data modeling tools also there are different activities that you do. Like for drawing, you can use something like a draw.io. You can use it or draw it in a piece of paper also, or data modeling. You can have a scratchboard where you can have. Then you have rubber banding, which is more like automatic redrawing of the relationship lines. When the entities you are moving from one place, then they will try to redraw it. So those things you can do. You can do a DDL, a forward engineering tool. You can use a metadata tool, and you can also use some of the spell checks, naming standards tools and all that you can use. Then you can also create a lineage tools, like will help you to map the data from where you want to bring in the data, right? For example, there is a data like for example sales amount. Now this might be sourced from different several applications. So the lineage tools will help you to do a source to target mapping that will help you to understand, okay, which data sets will needs to be brought in from which database, which table entity, and has to be moved to which target. So that is on the lineage tools perspective. Then data profiling tools you can use to profile the data sets, to underline, see what is the underlying data, start looking the exploring, do an exploratory analysis on the data, doing a statistical analysis to identify what the number of unique data, what are the patterns, data patterns, all of it is something that you can use. Metadata repositories you can use for identifying the definitions. You can identifying some of my, associated metadata linkages that might be required. So you can use these metadata repositories to get a lot of these details, the catalogs and all that can start also giving a lot of information that would be useful when you are creating the data model. You have the data model patterns, so these data model patterns are nothing but they will help you to identify what kind of relationships is there. Is it one to one, one to many? So these assembly patterns primarily help you to understand the business association with these teams, the assets, the documents, the project organizations, these kind of things also. It will start providing you this information and the integration patterns between them also. And then you can also use some of your industry standard models. As a lot of times during your data modeling exercise, you also want to use a model that as a starting point. So you can use some of your pre-built industry standard models, like across the different industry, you have some of these models like healthcare, insurance, telecom, they have. And some of them, like you have the IBM in the data model, banking data model, you have the Microsoft provides a data model for banking. Then you also have, a data model which some of your business, like your Bayan provides the data model. Some of them, like these data models that we provide, are like industry specific, industry, industries, models, data models, which you can use and make it more tailored to your organization. That becomes also the starting point. Now you can see these all are available in your data catalogs, the metadata repository, profile information, lineage, and data modeling tool. And then these are nothing but your reference that you can use, the reference industry standard model, data model patterns, which you can use as part of it. Now, there are certain kind of best practices when you're creating your data model that you can use. Like, for example, you can use the ISO 11179 metadata registry. That would be is more like an international standard, which provides on details on what are the naming windows should be used, what are the naming conventions, definitions that should be there. So this is a lot when you start using. You standardize. You also do something called as metadata standardization as an exercise, so that will start giving you a lot of these guidelines. Otherwise you see that the definitions is like you have customer name and the definition is like name of the customer. But now if I want to have a ISO 11179, then I can say name of the customer, which includes your first name, middle name, and last name. This is something that uniquely identifies a customer from another customer in case of conflict. So when you start giving a detailed description or detailed definition, then based on the standard, it gives a lot of context and value, right? Otherwise, it's just for the name's sake, we want to provide something, we are just providing it. So that is one thing. Then you also see some of the other things as part of the naming conventions is there are certain kind of IT standards that you might be having, some of your internal policies. So you also start aligning and seeing them that whether they are aligned to your, objectives that you have. Then is it meaningful to the business? The business are able to understand it. Is it something that you're using too much technical jargons and all or not and trying to keep it simplified? You are having the business rules captured very clearly. So these kind of things. And one of the other thing that you should see that it should basically not keep on changing across, the different data sets or different environments. That's also very much important. And then with some of the best practices in database design includes the performance, the ease of use. It should be reusable across other applications and across the other data sets, for multiple purpose. The integrity aspect, it should have a valid business name, business value, context, all of it is something that is there. On the security side of things, it is something that should not be immediately available to any unauthorized person. The privacy related aspect should be taken care of. And the maintainability, what is the cost of creating, storing, maintaining, and using all of these data sets? It's something that also speaks about. And once you create this data model, the last part is the data model and the design aspects, so data model governance. So for the governance aspect, you can see that um, this is something that it's not like it's a one-time activity because data will keep on changing. Tomorrow, new sets of data might be coming in. So the data model should also be able to scale up to any of your future requirements. So that is your entire component. So in the first step, you primarily define the data modeling and design standards. So under that, you define certain standards with respect to a list of all the descriptions of the data model design deliverables. What are the standard names? What are the abbreviations? What are the abbreviations that you want to start using for any of your different other data model objects? Then you also start keeping a list of all my naming formats, naming conventions, the standard methods that are being followed. What is the metadata properties that I want to capture? What is the design, the team's roles and responsibilities? What is the expectations? Can I start creating certain kind of metrics, right? Then second component is try to review the data model continuously and start seeing that is there a better way of from a design perspective, can I start having a better design? So you can have review meetings, you can start reviewing the data model, having periodic reviews with the different teams helps you to understand and optimize the further design aspect of the data model. A lot of times, sometimes you might have to group the data model and have a better approach in creating something called as universals for the different set of users. So that is another thing that comes on the design modifications. Then how you manage the data model versioning and integration, right? So versioning is also very much important. So you also should be able to capture implement the change control to see that in case if there are changes that are happening, I should be able to preserve whatever the changes that has happened. So we have something called as the SCDs that we also use, like the type 1, type 2, type 3, type 4. So at a point in time, I should be able to identify the historical data sets, what are the changes that is happening. So SCD types and all also helps in when you're creating the data model. Also slowly changing dimensions and SCD types helps you in identifying what are the changes that is happening, so that is also. So these should capture and that will capture the changes, but why the changes is happening, who has initiated the changes, what has it been approved. So that is all from the governance perspective. And then you can start having a metrics, a data modeling metrics, so or measuring the data quality models quality and all. You can have these data model scorecards that will help you to identify. So how well the data model is capturing my requirements, how complete is my data model, how well the data model match its schema, how structurally sound is the my model, how well my data model leverage generic structures, how does my model follows my naming standards, how well has the model been arranged for readability, how good are the definitions, how consistent is the model with the enterprise, how well the model metadata match the data. So all these kind of things, you also can create a entire metrics scorecard around it and start publishing. So these kind of things, it's not like a one-time exercise. As you start create periodically trying to check this data model effectiveness, that will help you. Right. So this is primarily on the governance aspects also that you start doing it, you start creating a lot of these things, aspects about it. So this is something on the data model where you start, identifying a lot of these things, and I've tried to show you a lot of these components as well. Let me just show you some of the examples that will help you to identify each of these things, what we are speaking of. Each of them has been explained in more detail separately, so you can also have a look at them separately. So So here you can see what are my different components, the entities, the aliases that we have defined. We have just seen the relationships, the attributes, the different types of domains. We have seen graphical representation, some examples. I've shown you some of them as well. The entity relationships and entity relationship diagrams, the cardinalities we have seen, the attributes, foreign keys, relationships, entities in respect to entities. Different types of schemes that we have. So this is more NoSQL is for big data, time-based is more for big data. You have the object-oriented and fact-based data modeling, where you have more of an app-based architecture. Then this is more things. Relational and dimensional is more very popular when you want to create an entire enterprise-wide data model for your data warehouses and all. So then for the structured data and all, these kind of data models are very popular. These are some of the notations that you can see that is being used, being just for a representation. This is an anchor-based data model. You can see an access-based data modeling style. You have the UML notations, you have the ORM notations, you have the COIM notations, a data wall which shows you the hubs, satellites, and the links relationships, and an anchor-based data modeling style. Yeah. Again, these examples of dimensional based physical data model versus logical data model, how it looks like. Logical will be having more of a business terms and all, but physical data model will have more of the physical terms, the physical, physicalized names, nomenclatures, and some of the technical related aspects around the data model. Now here you can see there are different types of data modeling styles. So you have the star-based data modeling style, Snowflake, Galaxy-based, schema-based data modeling. So in a star-based data modeling style, what happens is you have the transactional tables which are there in your center, and you have the different types of dimensions which are there, which are more static tables. They would be connected with my transactional tables, right? So this forms in the form of a star. Now in Snowflake, what happens in Snowflake-based data modeling? What we do is these dimensional types data models could be further divided in normalized further. So you still have the transactional based data model in the center, but then you have the dimensional data models that has been connected with them. They could be further normalized and they would be having that. So like that, you can have a Snowflake. And a Galaxy-based data model is a kind of now where you can have multiple transactional tables. They would be connected with my intermediary dimensional tables, and they would be useful for connecting or showing the relationships between the data. So here you can see the different types of in the physical and types. These are something that we discussed. What are some of the things that will come in the conceptual, logical, and the physical data models as well? And then we have something called as my normalization. So we have the five normal forms. We have the first normal form, second normal form, third normal form, Boyce-Codd normal form, fourth normal form, and fifth normal form. First normal forms is where we try to remove any kind of multi-value attributes associated in them. In second normal form, we try to remove any kind of my partial dependency. We have the partial dependency. In third normal form, we try to remove any kind of a transitive dependency. Now, Boyce-Codd normal form is very similar to my third normal form. The only thing is we try to resolve any kind of an overlapping candidate schemes which are there. And then we have the fourth normal form where you try to resolve many-to-many relationships. And in my fifth normal form, you also try to resolve the inter-entity relation dependencies, right? So normally I've seen that organization keep it with BCNF because fourth normal form becomes too much um, try to over normalize the entire data sets, how they would be kept in. But there are organizations, the data models, and certain use cases where you also go and try to resolve many-to-many relationships between the data sets and try to resolve the interdependencies in my fifth normal form as well. So you can see that fourth and fifth on then occurs very rarely. Yeah. Then you also have something called as my generalization to abstraction that we can have, that is generalization and specialization. These are primarily when are more useful when you want to, with respect to yours, you have something as a security as some of your specific things, right? So subtypes and supertypes or abstraction primarily includes a lot of generalization and specialization. So in generalization, which is your supertypes, what happens is, in here what you're trying to do is you're trying to group your common attributes together on the relationships of these attributes, right? And whereas in subtype, what you're trying to do is you're trying to create these the roles or the classifications. You're trying to have separate entities, instances of entities into groups. For example, you have a party as, right, as one of the entity. Now within that party you can have an individual as a subtype and an organization could be as a subtype. So like this you can have. Whereas like you have the university and high school, which are my subtypes of my supertype, which is my school, right? So like this, what also does is subtype and supertypes also help you in reducing the redundancy on my data model. So here you can see my school, which is my supertype, which will have the subtypes, which is university and high school. So it also helps me in reducing the redundancies in my data sets. So here you can see this is something that you'll see around data models, across how it is being done. So this encompasses the entire chapter on data model, all the different aspects around it and all. It doesn't give anything more on the practical side of things, but whatever the things that are being done right now, how to use some of these things in your data. So this entirely it's a kind of concepts that is being done, but when you actually do a data model design, you will have to use all of this. You start with the conceptual model, you get the requirements, then start with the logical designing component, and when that also, which is the type of data modeling that you're using, whether you're using an object-oriented data modeling, and entity-based data modeling, a dimensional-based data modeling, a data vault modeling, right? It all depends on it, and accordingly, the steps, the stages that are that part of it will be accordingly change. Okay. So I've also covered the governance aspect, the metrics aspect, the way that you are required to view, capture a lot of these things. So that is how it is being done. Then each of these topic, is it's itself is a big area. So data modeling is a combination of business, is a combination of your data modelers who will be actual modeling. It's a combination of your developers who would be able to construct it. So it is something, data modeling as something that includes a lot of people, actors. That's the reason you can see it is not like one person would be able to do all of this together right from start to end. Though there are people who have been doing it, but that comes with a expertise right from the industry, from the business, as well as having a technical understanding of each of it. Okay. I think that is something I wanted to cover on data modeling. So let me just see if there's any Q&A and questions if you have in the Q&A section. I'm gonna share this recording. I'm gonna upload and you can go through it and you can see if there's any questions. You can reach out to me and accordingly I'll be able to resolve. Okay. I hope you like today's session as well. There's a lot of things I would request you all to go through and read through it as well. Each of these topic is very detailed in itself. Cannot be accommodated in one hour itself. It's a big course in itself, but we are just trying to squeeze it into the required available time. And if there is any questions around any of these, there are different data modeling solutions also out there. You have the Arvind Data Modeler, you have the SAP Power Designer, you have the Lucid Chart, you have Draw.io, you have so many other data modeling tools which are out there that can also be leveraged as part of the entire data modeling. Okay, so I will leave you guys here and I will meet you in the next session with another topic on data, and we'll deep dive into each of these different aspects as well. All right. I can see some Q&A. Yeah. So how do we choose the right data modeling, the tool that fits into the organization? So what are the key considerations? Good question. So one of the key, what is the, well, if it is with respect to the tool, so few of the things that you require to understand is whether the tool, what is the data modeling style that you're using? Is it like a UML, object-oriented? What kind of notations that they serve? Second is a data modeling when you're creating, it also have to be physicalized, right? So these data modeling tools will have, it should have the direct connectivity to the database so that whatever the data modelings that your data models that you're creating should be able to physicalize in the target database. So that is another key component that you should see. Then does it support data versioning? You know, whether it supports data modeling only for your structured data or your unstructured and NoSQL kind of databases also it supports. So all of this takes taken into consideration basically you do. Some of the times it also helps you to send notifications, you know, whatever has been made changes, you know, into your databases. So in case if it is able to read, wait and see and provide a notification to the data modeler that something has got modified. As a process, you see that anything that is getting modified in the database should be first be designed into the data model and then it should be physicalized. But sometimes it happens in business in actual scenario that the DBAs will go ahead and modify the final state of the table, but the data model still remains outdated. So that should not all happen, right? So what you have is these data modeling tools also have the capabilities that capture in case if there is any changes that has happened. So from a governance perspective, it becomes very easy. Then the design aspect, you know, does it show a final view of your data model? So all these kind of different things are there. You can also refer to the Gartner's data modeling analysis. So they have done a different set of other key considerations that comes in that you can use there. Data Vault, if you see, I've shown you, right? Why Data Vault is becoming more popular is because of the newer types of data that is coming in. You know, when it comes to your streaming kind of data, unstructured kind of data, Data Vault is getting more popular because it has more efficiency with respect to handling these different types of data, big data types of data sets. And Data Vaults is getting used along with your data, normally data vaults are not being used in its raw form, but they are being used in associated with your dimensional based data modeling, you know, styles. So, like for example, in Snowflake, at first level you want to do a more of a dimensional based data modeling, or first level you want to do a more of a data vault like data modeling, and this data vault models feeds into your dimensions and your facts. So that primarily because it captures a lot of your, the changes that is happening in your data sets. Efficiently, it has been found that it is able to capture it more efficiently as compared to your dimensional based model. So that's the reason data vault modeling is getting a more things to handle a newer types of data, which dimensional based modeling to some extent has certain limitations. It's a combination. They are using a lot of organizations. They're using data vaults. There are still a lot of organizations are still going with your traditional data dimensional based modeling as well. So it again depends on what is your business requirements and what is the scenarios that you have in it. Okay. All right, guys. So I think that's it from my side. So I will stop the recording as well. And I'll meet you guys in the next session with some of the other topics that we have. So you guys